Live from Harbor Station, it's the Vector Spaceman Show. Now, here's your host, Vector Spaceman.
Hello, Space Cadets. It's your old pal, Vector Spaceman. We're back at it again, man. Coming to you live once more, straight from Harbor Station, and broadcasting live on all frequencies to our beautiful planet Earth. Now, whether you're watching us live or catching us after the show, don't you know we're glad to have you on board. Thanks for helping us keep outer space the place to be on tonight, January 16th, 2024. Hello, Space Cadets. Welcome back to the show, and if you're just tuning in for the very first time tonight, welcome aboard. I'm Vector Spaceman, your one and only host of this one and only Vector Spaceman Show. And we are continuing to dibble and dabble in new tools, software, and creative expression. We're being big old nerds tonight, and we're getting into our first exposure to Godot, the lightweight, free-to-use, open-source game engine punching above its weight class and trying to be the next big thing in independent game development. We are going to be seeing if it's intuitive enough to let us make something cool tonight as we continue to add new tricks, and tips and tools to our arsenal in service of the future of cool Spaceman projects. Oh, we got bad stuff in the chat. We got bots. Let's get rid of this. Bam, gonzo. Now, if you missed the last show, we continued our 2024 trend of creatively inclined streams with our first exposure to Blender. We made a donut, we made some sprinkles, we struggled our way through unintuitive hotkeys, in a sense, but we came out of it all the wiser and better off, I think. Most definitely. I feel like we're going to grow to like and appreciate Blender more and more, especially as we use it to craft the mythical Spaceman 3.0 coming soon. Ooh. Now, will we be able to synergize all of our new endeavors into something truly remarkable and space-manish? Animation, 3D modeling, game dev. Why, what could be in store for the future of the Vector Spaceman Show? Well, for that, you're just going to have to stay tuned. And speaking of which, if you want to stay up to date with all of our broadcasts so that you never ever miss a show, then be sure to follow Vector Spaceman on Twitter, YouTube, and of course, right here on Twitch. All right, you guys, let's get into things, shall we? Hey, you guys, welcome back. Welcome aboard. Happy Tuesday. It's the show. So, we are getting our hands on some new tech tonight. We're finally getting around to trying out Godot. Why not, right? Godot, of course, getting more and more popular due to the failing star that was Unity. People not liking some of the proposed changes to the Unity licensing model. And so more and more game developers are making the jump to other available game engines. Now, I've used Unity in the past. I found it nice. I found it serviceable. And I'm looking forward to seeing how Godot compares. The main selling point, and kind of the reason why I decided this would be a good alternative engine to try out, is that Godot supports C# as a scripting language, as does Unity, but chiefly because I don't love learning proprietary languages, like Godot's built-in GD script, which I can only assume stands for gosh darn script. Hello, Nep. How are you doing? Indeed. That's the kind of noise you got to make on a Tuesday. Well, thank you for the little hydrate redeem. Thank you so much. Let's all stay hydrated, you guys. Take a little chug, take a little swig right here. Let's all enjoy. Let's all imbibe. Let's all indulge. That's good liquid. Thank you for that, Nep. But as I was saying, C# has always felt good to me. I've used it for personal projects, I've used it for game mods, I continue to use it. To this day, it's a lovely little language, so why mess things up, am I right? Am I right? I feel like I'm right. How are you doing tonight, Nep? Thanks for showing up, thanks for stopping by, thanks for dropping redeems. We're going to be doing a little game dev trial tonight. Not really game dev in the extreme sense, but just getting used to a new game dev environment. It's our first time trying out the Godot engine, so we're going to see what we can get done here. What seems intuitive, what seems like stuff that we're used to. Maybe put together a little something that we can include here on the show, a little functionality perhaps. So what we're going to be looking to do tonight is get familiar with the Godot workspace, figure out how to make like a player controller, very basic stuff, maybe talk about how we might implement it into some projects here on the show. And of course, all the while, we're going to be chit-chatting with my favorite space cadets in the world, that's you guys. So take a seat, cadets. Get your notebooks out. Maybe we'll all learn something tonight. or just keep Spaceman on in the background as you cruise through the evening and keep on keeping on with your week. I know you're doing your best, and I hope you're doing well. So let's get our game dev hands on. Hold on here. What can we throw on here? How about the little, how about the tablet? That looks good enough. And let's head on over to the big screen, you guys. All right, here we go. Make a swift little transition here. Wow, and we gotta pull up the scene. And we'll just let that fade right in like, bam, here we are. It's Godot. Or I've heard some people pronounce it Godot as well, which to me sounds wrong. Even though the icon, even though the logo is a little robot, you'd think that would make sense. So actually, now that I'm thinking about it, maybe it is Godot. But I see Godot, I think Godot, because I was a theater nerd, and because they made us do that play back in the day. And so of course that's the only name that I associate with it. What can we do here? Why don't we? Hold on a sec. Let's find some good working music, shall we? Let me close this down for a sec. Let me pull up my the old YouTubes. Okay, we can throw this back up now. Had to open a different browser. Let's see if we can't find some working music, some accompaniment, if you will. Let's see. Subscriptions. It's about should use. Yeah, here we go. Find something nice to listen to while we tool around. Videos, let's see. Something nice and instrumental, huh? Something we could throw on in the background. Where's that one we used the other week? When we were doing doodle streams. Let's see. Something similar. Yeah, I like that one, so let's give it a go here. Here we go. Okay. Whoa, geez. I think it picked up right where we left off last time. All right, here we go. Back to the show, back to the stuff. So here we are in Godot. We've got a little test project open, new scene. So the thing that's interesting, first of all, let me just say how much I appreciate when I downloaded the installer for Godot today. I thought we were going to get hit with, all right, you got to unpackage stuff, and then you got to install it, and then maybe it's going to give you like a hub that you have to navigate through to get it set up. But no, it seems like as soon as you download the executable, it's just running. Like, it's very lightweight, and I appreciate that a whole lot. I don't like game engines that have got a whole lot of bloat, a whole lot of extra stuff in them. But the thing about Godot, it looks like it comes set up to work either in a 3D environment like we got here, or as a 2D environment. Looks like this is the outline of what would be our screen. That's lovely. And my understanding is that it's similar enough to Unity in the sense that it's got what it calls nodes, whereas Unity had game objects. But they function along the same principle, which is that you've got nodes or game objects, you're attaching scripts to them, the actual bulk of your programming, and getting them to run and do stuff. And so that's what we're going to try to do tonight. So for example, if we just, let's say if we just, if I hit F5, no main scene, or if we just hit, okay, same thing. We gotta make a scene. So if we hit 2D scene, node 2D, what? I don't know what we just did there, so let's get rid of that, because I would rather see it show up. Here we go, new scene, 2D scene, that's what we want to do here. We're gonna mess around Scene name, we'll call this, well, we want it to be our main scene, right? So let's just call it main. I don't know what the difference between all of this stuff is. SCN presumably stands for scene. TSCN, that stand for 2D scene or turbo scene. And then RES probably stands for resource or something like that, but this is what it gave me as the basic, so let's just go with that. Okay, so we've got our main scene here. This is what we're looking at. These are the bounds of our scene. And we have nothing on our canvas, if you will. All right. So instead, we are going to create, let's say, okay, so I think I'm getting an idea. Okay, we can create new nodes. These are all our available types of nodes. Is there something like a player controller? No. But we have something called a node 2D, a 2D game object, has a position scale, all that stuff. Okay, so let's go with node 2D. So within our main scene, we now have a 2D node, and we're going to call this the player. And that's great. Now, in order to get this player to show something, because right now it's showing us that it's right there, we can move it around, but it doesn't actually occupy any, like, draw space. Right now it's just a point of data. So I'm guessing if we were to run the program right now, let's see. Actually, let's define where we do that. Project settings. Main scene, okay. If I pull this, oh, dangerous. Dangerous, I'm just gonna move that over here, but yeah, we wanna choose that main scene. And now if we run, look at that, we just get a big blank empty screen, and you can't see our player node because it doesn't really exist. Well, it exists in the sense that it's data, but it doesn't have any sort of like visual element tied to it. So if we wanted to turn that into a sprite or something like that, then we would have to find a corresponding like sprite node or something. So let's see if we can add a child node to the player, and if I search for something like sprite, look at that. We can add a sprite 2D, we can add an animated sprite 2D if we wanted to add animation to it. But for right now, let's just add a sprite 2D. And that would allow us to load a texture, image texture, texture atlas. Set a number of different properties. Okay, this is interesting. We can have it. We can even offset it from the transform value. That is the XY value of the node 2D that it's attached to. And we should actually be able to... Alright, I'm getting little updates in the console here about where we're moving this to. That's nice. Is there a way for me to actually set it? There it is, okay. So, when we move this around, those values change. The position values. It's got a rotation value. It's got a scale value. We can make that huge or reset that back to 0. This will become more evident when we add a sprite to it. But actually, I didn't even think we should make ourselves a little sprite. Let's do that, why don't we? I guess we could use... Oh, we could freehand something real fast. That could be fun. Let's pull up everybody's favorite sprite editing software, Microsoft Paint. Oh, but you know what? If we use Paint, then... Can you save a transparency value in Paint? Should have gotten one of those sprite editing softwares to go along with this. Okay, in that case, for now, let's just use Spaceman's face. I've got that saved somewhere here. Let me just pull that up. For this Sprite 2D, the texture that we're going to use is a new image texture. Presumably. That sounds right. load that image texture. Okay, now let me go find. Because it's saying that we can load in a PNG, and that's great. Okay. Oh, but you know what? It says that I can't load from outside of the... Like, I can show you guys here. It's saying that you can't load from outside of the, like, root folder for the project. Okay, so in that case, I'm just going to do this off screen here, where you guys can't see. We're gonna copy a Spaceman face from our saved pictures folder. We'll get a nice smiley one, there he is. And we're gonna copy that into our root folder for the project. It's here. Oh, hold on. You know what? For some reason, our project folder isn't showing up, so maybe it's because we haven't saved this yet. So if I go save, okay, now is it there? Godot projects. Odd, why isn't it showing up? Alright, I'll put it where I think it's supposed to be. And now, let's see what happens if we try to load. Yeah, there he is. Spaceman face, and it's huge. Okay. So we are going to scale that down just a bit. Can we? Yeah, nice. Snap it? Yeah, that's great. But actually, can we snap it to... Okay. And snap it to the root of the parent node. Or wait, which one's the parent node? That's the parent node. Okay, so we want to snap this right in dead center of that. Okay, so now, when we load this up again, look at that. We've got a Spaceman on the screen, but he doesn't do anything. So we have to add some functionality to him here. And this is where the scripting comes in. So we are going to create a new... We create a script right from... Okay, so no, that's the scene, and this is the resources, I guess. Okay. Now where it says language here, we want to change that from GD script, which I don't know, to C#, which I am familiar with. It's going to inherit node, class, okay. And we're going to call this... What are we going to call it? We're going to call this player controller, because this is going to be what allows our Spaceman face to move around the screen. Okay, and we're going to hit create. Now, if we double click on this, what is it going to do? It's going to open up, okay, a built-in editor. How can we change that? Because maybe we'd like to edit that in a different editor. Because I'm guessing I go like Godot dot... Yeah, we've got no, how you say, like helpful features. So let's close out of that. Let's go project settings, editor, no. File systems, no. Duration, no. Editor settings, though. Oh, hold on. That's it. Okay, external editor. And we're going to use Visual Studio, because that's what we got installed right now. But now, if we double click on our Select again. That should... Okay, that opens up the studio, which we can drag over here. And now, yeah, that's better. Because now... should help us do stuff. Yeah, okay, here we go. Like it's auto-filling stuff for us. This is good. Shows us everything we have access to, all the different classes. Fantastic. All right, so what do we want to do? So it's telling us here that this underscore ready function and underscore process function are what come built in with the node class. So underscore ready gets called when the node enters the scene tree for the first time, so that means when it gets instantiated, essentially. So anytime that our node, our player in this case, gets created, it's going to do whatever's under the ready method. Similarly, the underscore process method, function if you will, called every frame. Delta is the elapsed time since the previous frame. So this is like the update call from Unity. Just a standard call that gets done every frame. So every frame that the game calculates, it's going to do something for us, whatever's in this process function. Now my question is, let's try, see if this works. Does it have a fixed process? Because a fixed process would actually be very helpful. No suitable method found to override. Okay, so it doesn't exist already. The difference there being, like, between update and fixed update, or process and some sort of equivalent fixed process, is that where an update will call every frame that is generated, a fixed update will call at set specific time frames, irregardless of whether of whatever your frame rate is. And that's useful because you can then tie that to your like physics calculations or anything that relies upon like real world steps, time steps, that sort of thing. Because, you know, people can have wildly different frame rates across games. It's not so important if you're working on like a single player game, I suppose, because you don't have to worry about like networking or anything like that, but for any sort of multiplayer stuff, or if you want something to, you know, occur at a reliable rate, based on like something that happens every second or every 5 seconds or something like that, instead of trying to guesstimate it with your frame rate by using an update or process call, use a fixed update or fixed process call. Pretty straightforward, right? I think so. Alrighty. But let's just play around with what they give us here. So for the ready call, I want to do something like print. We don't have. I'm just going to try to print a message to the console. Let me know that it's working. Godot.print. No. Thankfully, we've got a handy dandy reference manual here. Godot's nice and documented, so let's look for print, please. Can I print something? Print text. WebSocket's fun. Yeah, show me how you do this here. Okay, yes, and we want this in sharp. Oh, sorry, not print. It's gd.print, of course. How could I have presumed? All right, so if we go back to our editor here, gd.print. So these are global Godot functions, I'm guessing, and we're just going to output a string. We're going to say player activated. That's good. Save that. tab back to our editor. Taken, reload the script. And now, when we run, it'll build. And did we print anything to the console? We did not. How come? What did we do wrong? What could have gone wrong? Now, mind you, that could just be because called when the node enters the scene tree for the first time. So because it loads and it's already in the scene tree, it's already instantiated before we even run the game. So instead, here's what we're going to do. We're going to move this call down to the call every frame function, the process function. And what should happen here, if we've done everything correct, is that it should output a long stream of messages. Let's reload again. But it didn't. Nothing happened. Oh, you know what? I know why it didn't work. Because we haven't attached our script to the actual player node. Okay, that makes sense. So we're going to move this back to where I expected it to be. And now we are going to, let's see, can we drag and drop these? We can. So we can attach it to the sprite or we can attach it to the player. I would want to attach it to the player node in this case. And now it shows, it tabs us over to that automatically when we click on it. That's great. That's good stuff. So now when we run it, we should get a little output there saying player loaded. Player activated, there it is. Okay, so it worked, that's great. So now we know that there's communication between the script and the node and the game that we're making. That's great, that's great. Whew, I was a little worried there. I was like, why isn't that working? That's pretty straightforward stuff. All right, now we can actually try to do something like get our little player to move around here. Our little spaceman face. Our little vector face man, if you will. Let's close that down. Let's go back here. And so what we want to do to get him to move around, we have to make some sort of character controller. And to do that, we are going to get inputs. And then we're going to apply that to a vector, actually, with an XY value. And then we're going to adjust the player node's position based on the input that it gets. So first of all, what does this give us? Input. So that's Godot.input, input.action press. Pressing the specific action. Action release. Get axis. Joy axis. Mouse button, so we can get all sorts of inputs. Is key pressed? That's pretty straightforward, right? For our purposes, that should be pretty easy to do. Set, okay. String name action. So we have named inputs. We briefly scrolled by it. Is action pressed? Okay. This is probably what we want to use right now, because it's pretty straightforward. But it's nice that we have options. Okay, and then we are going to have to name our action. So let's say input.isActionPressed. Move right. We'll call it move right. And we want to encapsulate this inside a condition. So if that condition has been met, so if input.actionPress move right, So if our right movement key has been pressed, and we're gonna have to tell the game what a movement right is. Where did I see it before? It was under project settings, I think. Yes, input map. So we're gonna add a new action. So presumably, we gotta name it. So if I want to call it move, or I might not even have to use quotes. So move right. Bam, look at that. But how do I tell the game what that means? Okay, we tell it what it means. It gives us a little event configuration panel here. Okay, so we're looking for keyboard keys. And we're gonna say right. Keyboard right. Okay, so now move right means when we press right on the physical keyboard. Thank you, game. Okay, we can go back to the editor now. That's all set up. So if it detects that that has been done, first of all, before we try to apply anything to our Spaceman, let's just do another print method here. So we're gonna say right key detected. That's just gonna confirm to us that it has been done, that it has been pressed. Load, and let's go. Okay, so we're watching our console here. The player has been activated. Now I'm gonna press right. Oh, look at that. And you can see that 1, 2, 3, 4, 5, 6, 7 frames were processed in the time that it took me to press and release that key. And of course, if we were to hold it for even longer, if I go back here, bam, you can see the number down there, the number of calls. We're in the 200s, the 300s, the 400s, big long log here. So as long as you hold that, every frame that it detects that that key is pressed down, it's going to move a little bit. And that's exactly what we're doing. So we're going to close this. Or sorry, I didn't explain that right. Every time that it detects that the key is down, it's giving us that little message. We're going to change that to actually apply movement to our node, our player node, which is representing the position of our character. So we go back over here. We're just going to get rid of that for now. Now, how do we do like this dot node? Oh, get node. Okay. We get node from a node path, get node of a node type. Can either be a relative path or an absolute path. Can we get it by name, perhaps? Node path path, or once again, let's consult the guide. Okay, get node. Let me just see if I can't find a better version of this. Hold on a second. Nodes and scene instances. Okay, I see here now. So here's a handy little example that they've given us. So first thing we have to do is assign a value to sort of record data for our node. So we are going to do something like this. Then we can get node of a type with a name. Let's see, a variable. Actually, we shouldn't store this here. We should store this call this private. I guess we do have to node 2D. So private node 2D equals get node dot get node. What was the code they used? Is equal to get node. Why can't we call this outside of a method? Godot dot get gd dot get node. Can't call it outside of an existing method. Okay. Well, we can still make this work because we can say node 2D. Dee Dee, how are you doing? Thank you for the stretch. Thank you for the hydrate. I hope you're doing well on this fine Tuesday. Are you doing well, Dee Dee? Are you having a nice Tuesday? Everybody, let's take a drink real quick. Got to keep our minds limber as well as our larynxes and voice boxes and you know, muscles in general. Take care of yourself, Spaceman. I do intend to. We're playing around with Godot tonight, a little game engine that I'm just trying my hand at tonight. Here's what we've got so far. We've got a little space face on a screen, and we're gonna try to get him to move around, and that's what we're working on right now. Pretty straightforward stuff. I'm used to working in C#, so it's nice that they support it. Doing well, by the way. I'm happy to see you working with Godot. I'm also learning it. Nice, nice. I'll show some of the external projects that I've been working on after we get our little space face moving. Sort of the reason why I'm interested in getting some little game dev projects into the mix, into the works. But what we're going to do here, we are going to set a private node 2D, and we're going to call this, or you know what, this is a node, technically already, right? Right, I'm pretty sure, so can we just call this get node of a type. Oops. It's going to be named, what did we actually name it? We named it player. And then can we set its position, its transform, position, no, what do they call it in here? The hardest part is often trying to... Okay, node 2D. Okay, so it's not just a node, it's a node 2D. D player dot transform. There we go. Dot, let's get the X value or the Y value or something. Okay, I'd want to print this just to make sure that we are capturing it properly. So that should work. That should give us an X value in the debug about where our node is located. And if that doesn't work, it's because I've done something wrong. Player activated, something has gone wrong. I think it's because it's looking for an attached. Yeah, so actually we should probably just be able to call this dot transform, no, this dot node player controller extends a node. Look at our documentation again. We have to call Okay, so we didn't assign a value. That could be the problem. So we're going to say node 2D equals. And then all this stuff here, we're going to just transpose this. And now we want to print, we got to give it a name, player. Now we can print the player's transform X value. So let's, whoops, I'm running this from the wrong spot. Gotta tab back over to Godot. And it still doesn't want to print for us. Is this because this would be silly? Do string? That would be very silly. That was the reason why it didn't want to work. Alright, well, that wasn't why. Okay. But if we can't access those values, then we're not going to be able to move our Spaceman around. This is all going to seem very straightforward and silly once we figure out what the heck it is we're doing wrong here. Let's review that documentation a little more. Okay. Tell me about getting nodes. You can get a reference to a node by calling the node.getNode method. For this to work, the child node must be present in the scene tree. Okay. If you have a scene like this and you want to get a reference to the sprite 2D. Okay. So we would be, I think I get what they're saying here. We would be able to make that call if we were calling from like the main scene. But because we're calling it from the player, we have to find a way to reference our own variables. So how do we do that? This is already, so this is useless to us. As is this. I'll keep it there just so I'm reminded of the mistakes that I made. This will return a Godot object. Get string name property. Now that might work, but that seems clumsy. Player dot transform. So it's guessing, it's guesstimating that it'll even be able to get these values. Let's see here. Why don't we just look up an example of moving a node? That'd be pretty straightforward, right? Let me see if I can find an example here. Godot, move node 2D. Looking for common ways to move. Show me the script. Excuse me? This will be interesting if this is actually the way to go about it. Apparently, we can just call self. No, that didn't work. That must be the GD script version. But this wasn't working either. So we go back to trying to figure out how to move a node 2D object. Godot, move node object. C# specifically. I remember in Unity, everything, and I mean everything, had a transform value. But for some reason, here in Godot, I say this dot transform, yeah, nothing comes up. Or this dot position. We gotta do a little digging here. Set node position. Transform position. Something about spatials. Stuff that was written over a year ago. Transform 2D dot. Set the origin. No. About the X value. Flip X. No, that doesn't work either. That's not what we want. That's not what we want. Position. No. No. Turned out to be harder than I thought. Just moving a little face around. This would be pretty straightforward in Unity, but now I can't get it working here. Okay. Move node 2D. From attached script. Would that be helpful? Because not only can we not move it by inputs now, which the inputs work, we know the inputs work. Because input seems to have a global class, or a singleton class. There's got to be some very straightforward and simple way to access the node that the script is attached to. Get node fetches a node, a relative path, or an absolute path. I just say node 2D player equals get node without specifying any additional information. No, that gives us an error. No, overload takes 0 arguments. So we have to specify a node path. So node, is there like a node path dot self? Or can I just specify a new node path? Get path. Can it be blank? Cannot implicitly convert node to node 2D. Okay. We have to get it of the type node 2D. And then we need to get path, get self, get index, get node, script. It's gotta be a real easy way. So if we don't specify a child node that we're using, let's see what happens then. And then we'll once again try to print the X value of the player. Okay, save that. We're gonna go back to Godot, reload, fire that off, and still nothing. Still nothing. Transform. Oh no! Hold on. Transform dot. Okay, no, that shouldn't have been a problem. But can we get any information from this is the question. So what else can we get? Transform has a position, it's got scale, it's got skew, it's got all sorts of things listed here. Visibility, texture, material. It's got rotation. Can we get any information? Transform, no. Okay, so it automatically breaks all of this stuff up for us. Okay. Actually, if we could print both of those, that would be cool. Let's do that. Let's see what happens. But it's not going to work for us, but it's a nice setup. Now, we're getting some errors here. Let's read into this. Okay. Object reference not set to an instance of an object. Node not found relative to root main player. Okay. We need to figure out what is like the self call for this. Would this work? No, cannot convert from player controller to Godot.nodepath. Nodepath dot. No. I'm seeing a lot of documentation for the GD script. Not so much for C#, which is what I prefer to work in. File paths. Self. Node self. Like I said, this is all going to seem super silly once we finally get it figured out. Can we do a this.get property or something like that? Let's see here. Property list. Well, that's nice, but I would rather just get a specific property. This dot. Get owner. Hey now. Of a type node 2D. Let's try plugging this in right here. Okay, we might be onto something right here, you guys, you fellas. Check this out. Yeah, buddy, there we go. All right, now we're getting information. Okay, so it all came down to just the very specific phrasing. We need to get the owner, the node owner. So the node that the script is assigned to. Okay. Is that the method that we should be using, though? It works. But is there another recommended way that they do that? Just gonna search real quick. Godot. Moving player. Moving the player with code. Okay, let's see. Get direction, get node. Oh, but you know what? So this is interesting. Check this out. Here's a little example that the documentation gives us. Sorry to keep that hidden from you guys. Showing how they might move a player around. So, like we saw what we were initially doing, we've got movement inputs, which gets applied to, in this case, they're moving a 3D object. They are encapsulating the actual movement in some other helper function, which I would love to see, because then we could tell if that's the best way to... Actually, I didn't even see this. Your first 2D game. Let's take a look at what they recommend here. Coding the player. Whoa, whoa. Okay, we got a player. We haven't even gotten to stuff like collisions. Alright, player speed. That's cool. Oh, the one thing I wanted to point out on that last example that we saw, underscore physics process. So this is their version, I'm guessing, of a fixed update. So something that is consistent. Now, where did we go? Let's see. Yes, all this stuff. We figured that out on our own. Animated sprites. Okay, so if they're moving, you play the animated sprite. That makes sense. Position plus equals. Can't just call position, can you? I'll be very upset if you can just call position. No, so again, once again, they're hiding information from us. At what point do you actually... Yeah, we're attaching the script. Fine. Script variables section. Is this some, like, built-in... Alright, this is gonna... It's kind of a wild shot, but we go back into here. Is there a way for us to... Copy property path. Position. Underscore, just lowercase position. If I were to call this dot position. Dot, no, this dot transform, no, again. The documentation is throwing me for a loop here because this should be like one of the easiest, most straightforward things. This is like, should be what the first thing that they teach you. So I do like this. This is very reminiscent of how you say Unity. We can put our own custom variables into the inspector, it seems. So if we go export, what we'll do a float speed equals 1 to begin. Now we go back to the editor. Is this going to show us reload player? Oh, because I didn't make it public. Is that why? Is that why? Whoops. Whoops. No, we don't get that? Open documentation. No, close that, please. There we go. All right. In that case, I'm not sure what the purpose of that export keyword was then. Allows us to set its value in the inspector. Click on the player node, and you'll see the property now appears in the script variables section. Is this true? Ah, stop tabbing me over here. Do I need to add? No. I hope this documentation isn't like out of date or something. We don't have to build it first, do we? Because I will. I'll build it. There it is. Okay, it does show up. We just had to build it. All right, so that means that we can do on-the-fly editing in the editor in this environment here, which is very useful. But it still doesn't tell me if there's any better way for grabbing hold of our self besides doing this get owner call. Now, mind you, we don't even have to set like a player variable. We can always just call the this.getOwner node 2D whenever we feel like it. Go underscore self, just for simplicity's sake. So we declare that at the start, and we say this dot underscore self equals get owner. And we're going to print this dot underscore self. We would find a better naming convention for this. X. And again, this dot self dot transform dot y. So we're printing two different values here. We're going back here, we're reloading, and we're getting the exact same output, so that's good. Let's try to actually move the face, huh? Wasn't that what we were originally trying to do? Like an hour ago? That sounds nice. That sounds like fun. Okay. So now we found a reliable way to assign a self value, I guess. We're gonna get rid of this. We don't need this running. Here's what we want to do. Remember when we had our input down here? So now we're going to say if the action pressed on the move right is detected, then we are going to say this dot self dot transform dot x plus equals speed. Can't modify the return value of transform because it is not a variable. Because it is not a variable, you say. The x value is a... Oh, because it's a vector too. Okay. All right, in that case, and speed is a float. So you know what? Let's consult that little guide that they gave us. Because they were, I remember seeing them. Velocity.x, so they're making a vector 2 and they're increasing its velocity. Okay. So they're applying a velocity value, which is pretty good practice. We're going to say velocity equals vector 2. And we're going to make it a 0 value, just for simplicity's sake, because we're going to be adding to it. And we're going to say, if the action is pressed, then you know what? We're actually going to move this outside because we're going to be adding different degrees. So our velocity gets called outside. We're going to say, if the action key is pressed, then velocity dot x plus equals 1, or plus equals speed, rather. And then once all of our checks are resolved, then we're going to apply velocity to the transform. I can spell, there we go. Plus equals velocity. And it's not going to let us do that because it cannot be applied to operands of type transform 2D and vector 2. Transform is a transform 2D. Okay, it's a little roundabout, but I think we should be able to apply it directly to the x value then. No, but we can't because we can't modify the return value. But how do we actually set the position of our node 2D? We can get information from it. Now we can't set information to it. Okay. Let's review our documentation here. So once again, they're making a new vector 2 to adjust location. Okay, collision, we don't have to worry about that right now. Position equals position. Position. But what is your position? Where are you setting position, my man? My dude? Position is a vector 2. I'm clearly not getting this. Oh, well, hold on now. The node has a position, but it also has a transform. But you would think... you would think that with the way it's set up here, that the position would be a sub-value of the transform, so that we would be putting .transform.position .x or .y or whatever. But no, apparently, Godot has decided that self.position should be its own thing. Okay, so we didn't even have to... Alright, what is position? It's a vector 2. Okay. Position.x is a float value. Okay, so we could have just said self.position.x plus equals speed. And that should work. Cannot modify the value of node 2d.position because it is not a variable. What do you mean, man? It's got a get set value. Just the position itself. Okay, so we were half right then. All right. So here's what we're gonna do. We are still gonna need the velocity. And then outside of all the calls, position plus equals velocity. That should work, right? Yeah, that should work. Look at that. Okay. Let's see if that worked. Moment of truth, you guys. We're gonna launch the game, and what happens if we press the right key? Oh, our spaceman, he's motoring. He's moving. Look at him go. Thank you for tuning in tonight, you guys, as the spaceman makes his long voyage off of the screen. Know that we couldn't have done it without you. Look at him go. And now this is the point of having public variables in the inspector like this. See, that spaceman face is moving pretty slow, but if we multiply that by 10, let's say, so speed is now 10. Oh, look at him go, he's a lot faster now. So we can make on-the-fly updates for testing purposes without having to go back into the code and change constant variables or anything like that. I like that. They did that in Unity as well. It's nice having modular inspectors like that you can change stuff around. I like that a lot. All right, so now we're gonna basically, well, first thing we're gonna do is we're gonna refactor all this into its own method. We're gonna say private void move. And this is where we're going to make all of our checks. We're gonna bump that out of there, we're gonna move that into the move. And we're gonna say, well, we're gonna clean this up a bit. So if the action move right is pressed, then yeah, that's right. I'm just gonna clean it up so it's not taking up so much space. There we go. And we're gonna just copy these lines. Move left, move up, move down. All right, and we got to make some changes here. So if we're pressing move to the left, then we're going negative on our speed, our times speed. We're changing these up and down values to the Y value. You're going down, you're going negative. There we go. So now we've got a nice vector 2D that will move based on all the keys that we press. And all we have to do to get that working is go back into our project settings, our input map, and we just want to make a new action. We're going to call this move left, move up, and move down. Left, up, go. Not page up, but up. And down. 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 There we go. Okay, and now when we run... Oh, silly me. You know what we forgot to do? Forgot to actually call the move function. So, every time that the frame updates, we're going to call move. And now it should work just fine. Whoa, whoa! Okay. There's just one thing that I got wrong. You can't tell on the screen, but based on the keys that I'm pressing, we got it wrong. So up in the top left corner here, that's considered 0, 0. That makes sense. So you go to the right, that's a positive on your x-axis. But down is actually, to go down on the screen, is actually considered positive on the y-axis. So because of that, we just have to make one small change, which is to flip around the plus minus on the up and down action press detectors. So now it works perfectly. Okay. Now the thing, we lost our musical accompaniment here. Let me just put on another one. Hold on. Oh, this sounds. That's a little sad. Let's try this one. Nice, that's a little more upbeat. Now the thing you might notice about the movement here... Where did you go? There we are. Is that when we move side to side or up to down, it's got a fixed speed, which we set to 10 at the moment. So 10 units or 10 pixels, I'm not sure what it is. 10 Godot units, whatever that might be. But when we go diagonally, which means when we're pressing 2 keys at the same time, and actually we can press 2 opposing keys at the same time. So for example, I'm pressing right, then I press left, and we stop. Then I let go of the right, and we go to the left. Then I press it again, and we stop. Because they're competing with one another. But when we go in a diagonal fashion, we actually move a lot faster. It's that Pythagorean theorem. Because a straight line to an object is faster than going like up and then over. Going like that. We're actually moving a lot faster. So what we need to do in this case is normalize our speed. And that involves doing a bit of math. I'm trying to recall how we actually do that. Usually a vector 2D, or a vector 2 or a vector 3 has a normalize function built into it. Let's see. Velocity dot normalized. Scaled to unit length. Okay. So instead of applying the velocity, we are actually going to apply the normalized velocity. And we are going to multiply that value by our speed. Cannot be applied to type method group and float. Well, hold on. Read only. Oh, sorry, because it returns. Okay, hold on. Can we make a... So we're going to say that the position here's what we're going to do. We're going to say velocity equals velocity dot normalized. Okay. Then we're going to say velocity times equals speed. That works. Then we're going to set our position to velocity. And that might solve our problem. We're gonna run it. Moving. We're moving. We're moving now at a consistent speed. So now when we go diagonally, we're not going super fast. We're always moving at a fixed maximum speed, effectively, or a fixed constant speed. So yes, we're moving diagonally, but we're moving diagonally at 1 unit or 10 units per frame. And the same if we're just going one direction. So now it should actually take us longer to go diagonally to a corner than to just go left or right to a corner. Which is what we want, because, as everyone knows, a squared plus b squared equals c squared, so traveling along a side c, a hypotenuse, will take a little bit longer. But that's reflective of actual speed. And look at me, so proud of myself that I remembered how to normalize a vector like that. You wanna be a game dev, you guys. You gotta know a thing or two about math. That's the unfortunate reality. Okay, so now we've got a little space face that moves around. But to what end? That's the question. Have we got anybody in chat who could help me test stuff out? I don't know. I was going to show off a little something I've been working on the side, but we might have quiet chat today, so we might not get around to demonstrating what it is we're going for here. So in the meantime, let's just see what else we can do in the Godot environment. So I did see that it's got a collision node. So we can apply 2D and 3D collision shapes. Provides a shape 2D to a collision object 2D parent. We scroll through all the different Node 2D items that we have at our disposal here. We've got bones, we've got cameras, we've got joints and lights even. Particles, lines, meshes, paths, skeletons, tile maps, touchscreen buttons. Very useful. We have regular buttons. Do we have regular buttons? Canvas items. Okay. So one of the things I always hated about game dev was making UIs. Because they never look as good as you want them to off the bat, and then I just get frustrated with them. But you do need them for your game to be navigable. Can we try to make a little button? I would love to make a little button. I don't want it attached to the player. I actually want it on its own. Can I take that off? There we go. Whoops, sorry, player, I moved you around when I shouldn't have. Let's try messing with this. Test button. there's our button. Button mask. Mouse left, mouse right, mouse middle. 8 pressed when outside. They give us some good options here. This is nice. We can disable it or not disable it. Test with it being pressed on or not. Text behavior. Well, this is very useful stuff right off the bat. We were to just run it here. Alright, we've got a button. And presume... Oh, hold on. Excuse me? Excusez-moi? It still thinks that it's parented to the player. We gotta fix that. Can we just reparent to main? Ah, there we go. Now, it still wants to move around. What is the deal? We delete. Just delete that node. Button 2. Move it around. Okay, so what's this telling us? This is telling me that and you know what? This should have struck me when we were getting those 0, values. I see a grid here or anything? Yeah, because that's not 1, 1 or 0, whatever. I think that our script is for some reason picking up the whole scene and moving around the whole scene, and with it, everything. Everything? Everything. Yeah, that's right. Oh, and this is why I wanted to show off scale later on, because look, when we scale stuff up here, we can make that spaceman real big, or real small, or put him back to normal. Okay, so that means we gotta go take a look at our player controller. So the get owner is not what we want to be calling here. Not this. Instead, this dot self should be we just say this? We just called this. Cannot implicitly convert player controller to Godot.node2D. Get node? Node 2D without a path. We do that without a path? No, we gotta give it a path. We give it a name. We just call it player, since that's what it's was before. Shot in the dark, but this might work. Nope, it doesn't. Okay. So we've made some, how you say, gains tonight. But at the same time, why? Why? Is there not a very simple way just to call your own values? This dot position, like this dot nothing. Couldn't be that. No. And look, we're getting so many errors here. Object reference not set to an instance of an object. Right, because the self is not being assigned to anything. Let's stop that. Stop that. Well, let's go back to trying to figure out moving players around. Move this out of the way for a sec. Move node from script. Make sure we're looking at C# here, because that's what we're coding in. How do we assign it to our node? Positions, global positions. I'm not sure what could be the problem. That's a real shame. Because everything I'm seeing in this documentation just tells you nothing about it's calling move and slide, but guess what? Character body 3D dot move and slide. Why not include this information in your demonstration here, my man? And also, I must not be reading this closely enough. That's got to be it. All right, you're setting up your inputs. We figured all this out on our own. You're getting the node, the animated 2D sprite. That's fine. That makes sense. Set your velocity to 0. Yeah, we know about this. You went and normalized it. That's good for you. Oh, I see that. $sign is a shorthand for... for grabbing a node. Okay. But that won't translate to C#, so we can't use that there. Okay, you're clamping it inside the bounds of the screen. You probably wouldn't worry about that. In an actual game, you just use collision detectors. Choosing animation. Yeah, I feel like that's not so important. I feel like the moving... Collision's okay. Collision's not really what I'm super concerned about. Is to add a function we can call to reset the player when starting a new game. Work on the enemy, but we don't have the player working. With the player working, we'll work on the enemy in the next lesson, but we don't have the player working. Because our mans isn't moving. I don't think you've shown us how to actually move. Attach script. Yes. Wait a minute. What happens if we player controller dot transform doesn't have a transform, doesn't have a position, doesn't have a position. Even though node what if instead of extending node we extend node 2D? And we can say this dot position. Oh, Spaceman. Spaceman. We got messed up by the autocomplete create script mumbo jumbo. Okay, so let me see if I'm right here. Boo, Spaceman. Alright. See, I knew it had to be a lot simpler than that, like, get node, get from parent or whatever. Okay, so now we've finally got a controller that is just applied to the one node. So that means that we need to write our scripts for the node types that they are attached to. That's not a huge deal. That's in fact, that's safe coding when you think about it. And in fact, you know what I think it probably was? We went down here and we said new script inherits from node, and that's why. But if we had clicked on player and said attach script, look, then it auto defaults to inherits node 2D. So if we had done that from the get-go, this never would have been a problem. it would have done that for us. Live and learn. Lesson learned, you guys. Okay. Let's see what we can do with that button then. So now let's try this. We're going to attach a script. It's going to inherit from button. And we're going to call this, what do we call this? Spin button. Okay. Now, what can we do with buttons? That's the question. Let's, instead of me fumbling through the IDE there, let's consult the doc. Buttons. Tell me about buttons. If button dot, sort of like a property. Icon, language, text. Hey Slimy, how you doing? Welcome to Tuesday. I hope you're having yourself a fine beginning to your week. We're doing a little intro dive into Godot tonight. We're making our little space face move around all over the place. And now I'm just trying to figure out if we can mess around with button implementations. Man, it took me a minute to figure out how to get some of this stuff going, because I wasn't following any tutorials. I'm just going off of intuition and stuff that I know from other similar game engines. I'm good. I got access to my old account that was whisked away by 2FA breaking, so two-factor authentication breaking. That is rough, but welcome back. It's always good to see you. And I'm glad that you got that sorted out. Be proud. I'm proud of you. Now this is a button. See also base button. Okay. Signals, that's what we want. So button down, button pressed. When it is toggled or pressed. This is on button down if action mode is action mode dot button press, or on button up otherwise. Okay, so what can we do here? I'm proud that I had Twitch on my iPad since I haven't used it in months, so it clutched up. Clutched up! Stay clutched up! Take a little drink here. Hover pressed, pressed. Properties, if pressed. Okay, let's just try this then. So every frame we're going to call if this dot pressed. But what's the problem here? It only appear on the... Oh, pressed is a event handler? I'm just looking for a Boolean. Button pressed. If button pressed. And then we'll just output. Ooh, sneezed there. Excuse me. So we'll just output to the log. Button press detected. And this will just let us know that it's working. And if it's working, then we can do other fun stuff with it. Look at that, button pressed. In fact, if we hold it down, you can see all those alerts piling up there. We're now at 246 alerts and climbing. Because again, that is being called every single frame. So rather than button pressed, we probably want to check when the button press is released. Release? No. Is button up when the button stops being held down. But again, that is an action base, not... Instead, we want to do something like public void button up. We can override it, maybe. Spin button up hides inherited member base button up. Override void. So that is what we mean to do. Cannot override because it is not a function. How can we use it here? Base button. Signals. Button up. We get any examples here, or do we just get the documentation? Okay. Is, what did they call it? An action something? This, because you're not going to overwrite it now. Plus equals, and this will tell it what to do when this happens. Okay. So let's call this public void, or private void really, because we don't want it being called from anywhere else. Run. We're going to move this outside of these. So this dot button up. Ah, okay. We're actually going to put this in the ready method then. So this will get instantiated, and then it will say this dot button up plus equals run. Now, is that going to work for me? Not convert void to system dot action. Okay. How about now? Not all code paths return a value. We want to GD print. This is me not even know how these action values or whatever function. GD print button press detected. Return action dot remove. To do what? No argument given that corresponds to the required parameter source of delegate, etc., etc. Man, I don't know nothing about event handlers. How else can we do this then? We'll just look up the doc. Button pressed. It's not what I was just writing. On the ready. Button dot press plus equals some function. Oh! Is it because... Man. Syntax. That'll get you. Okay, so that should work now. I was 99% there. Now we're gonna press the button. Button press detected. Okay, so now when we release the button, it says press detected. Nice. And only once does it happen. Every time you click it, we can hold it down and it doesn't spam like it did before. With the, how you say, call for every frame. So that's great. We're making strides. And that might not seem very impressive for tonight, you guys, but for our literal first night working with Godot, there's a lot you can do with just inputs like this, button presses, multiple scenes and what have you. We're going to be making some cool stuff in the near future. I can assure you of that. But for tonight, I think that's probably where we're gonna call it quits. Because my legs are getting a little sore sitting like this. Ah! And we've still got lots and lots of stuff that we're working on, so we'll be back again shortly though. For now, let's get ready to close out the evening, shall we? Thanks again, you guys, for tuning in, for being here. Dust off my hands here. Let's go back to the main screen. Here we are back at the station. Now yous know that we don't just want to call it quits. We're gonna go say hi to some friends. How does that sound? And who should we go see tonight? Who's streaming? Who's having fun? What sounds like a good time? Let's see here. Anything topical? Anything similar? You know what? We're going to go see friend of the show, Maven. That's who we're going to see. Who's playing Sea of Stars tonight. We like stars. We're all about stars here at the station. So let me get that raid set up real quick. And remember to say nice things to Maven, you guys. Maven, of course, one of our stars from the latest Vector Spaceman animated special. And what a great job she did. And who knows, maybe we're going to see her in some more stuff in the near future as well. We've got some more shorts and things coming out. Stay tuned for that. All right. But that's it for us here tonight, you guys. So, as always, I want to thank each and every one of you for tuning in, no matter where or when you are. You can join Spaceman again, same time, same place, next week, Tuesday, 8 p.m. Eastern, live right here at Harbor Station. We'll catch you on the other side, Space Cadets. Until then, of course, no matter what life throws your way, good luck and Godspeed. This is Vector Spaceman, signing off. Now stick around for that raid because we're about to send you off for some more great content for your evening. Thanks for joining us here tonight, you guys, as we continue with our little learning streams, checking out new tech, new creative endeavors. We're going to keep it going. We've got some big ideas in mind for the future, and I can't wait to get to show you guys what we're working on. All right, but for now, that's it for us. So long, you guys. Say nice things to Maven. We'll catch you again real soon. Bye-bye.